Okay, welcome everyone. We've got some really interesting material to unpack today.
You do indeed.
You shared a set of practice questions, along with explanations, from the HPE2-E83 exam. Now, while it is exam prep material,
Right, but the value goes way beyond just passing a test.
exactly, the real gold here, I think, is how it highlights some of the absolute core technologies driving enterprise IT right now.
Absolutely. Think of this less like exam study and more like a shortcut to getting up to speed on some really critical areas.
So our mission today is to kind of use these questions as a springboard, right?
Precisely. We'll extract the most important insights, the key takeaways about things like AI and security, AI in the cloud, too.
Edge computing, which keeps coming up more and more.
It does. Then there's secure access control, automation, the big shift towards zero trust security.
Right.
Optimizing cloud resources, super important data governance, especially in multi-cloud setups.
Which is a headache, I hear.
It can be. Also, IT sustainability, using machine learning for anomaly detection and, just getting visibility in complex hybrid cloud environments.
Oh, that's quite a list.
They're not just random topics, though. These are the key conversations, the real challenges and solutions people are grappling with across the tech landscape today.
Okay, let's dive right in then. The first question you shared, it was about the benefit of AI in network security. And the answer highlighted real-time threat detection and response. Now, security is obviously vital, but what's the game changer with AI here? Why is it so different?
Well, the truly transformative thing about AI and security, I think, is its ability to move beyond just reacting to threats we already know about.
Okay, so not just looking for known viruses or malware signature.
Exactly. Think of traditional security sort of looking for those specific patterns it's seen before. AI, especially with machine learning, can analyze just massive amounts of data about network behavior.
Behavior.
And it can identify subtle deviations from what's considered normal, anomalies, things that might indicate a completely new or really sophisticated attack that doesn't match any known signature.
So it's not just recognizing the usual suspects, like you said.
Yeah.
It's spotting someone acting suspiciously, even if we haven't flagged that specific type of suspicious activity before.
Spot on.
How does that actually translate into real-time response, though? Is it really instant?
Well, real time is maybe a slight exaggeration, but it's incredibly fast because these AI algorithms can process and analyze data so much quicker than any human analyst.
Right.
They can spot these anomalies almost as they happen, milliseconds sometimes.
Okay.
And this allows security systems to then respond automatically, immediately, maybe blocking malicious traffic or isolating a potentially compromised system.
Or just alerting the human team to take a closer look?
Exactly. Alerting them before an attack can really escalate and cause, significant damage. It's kind of like having this incredibly vigilant, super fast security guard watching everything constantly.
That makes sense. Is there a downside?
Well, one potential challenge sometimes is what people call alert fatigue. If the AI is maybe too sensitive and flags too many things that turn out to be benign.
False positives.
Right. Then the human team can get overwhelmed. So tuning it correctly, finding that balance, that's an ongoing process.
Got it. Okay, moving on. Question 2 was about deploying IoT devices in edge computing environments.
IoT and edge.
And the key factor highlighted was efficient local processing capabilities. For someone maybe less familiar with edge computing, why is processing data locally near the device so important for IoT?
Yeah, good question. Imagine, say, a factory floor. Hundreds of sensors collecting data constantly, machine performance, temperature, vibration, whatever.
Okay.
If all that raw data had to travel all the way back to a central cloud data center for processing, then analysis, before any action could be taken, you could run into serious delays, latency.
Right, the time it takes for the data to travel back and forth.
Exactly. And for many IoT applications, especially ones involving real-time control, think robotics, or maybe safety-critical systems, those delays are just not acceptable. They could be dangerous. So what edge computing does essentially is bring the processing power closer to where the data is actually being generated, out on the edge of the network, near the IoT devices themselves.
So the intelligence is right there where the action is happening, so to speak.
Precisely.
Can you give a quick example where that low latency is absolutely critical?
Sure. Think about an autonomous vehicle.
Okay, yeah.
It's got cameras, LiDAR, radar, tons of sensors generating huge amounts of data constantly. It needs to process that data in milliseconds to make split-second decisions. Steering, braking.
You can't wait for a round trip to the cloud for that.
Absolutely not. Sending all that raw data up, waiting for instructions.
Yeah.
Far too slow, potentially catastrophic. So processing that critical information locally, right there at the edge, on the vehicle itself, is essential for it to operate safely.
Makes perfect sense.
And there's another benefit, too. Processing locally often reduces the amount of data you actually need to send back to the cloud. Less bandwidth usage.
Which can save money, especially if you have thousands of devices.
Exactly. Significant cost savings, potentially.
Okay, cool. Question 3 then zoomed in on Aruba ClearPass and Secure Access Control.
Right, ClearPass, NAC Network Access Control.
And it pointed out 2 key features: role-based policy enforcement and device profiling and authentication. Let's unpack device profiling a bit. What does that actually mean?
Device profiling is essentially about identifying and categorizing any device that tries to connect to your network.
Okay, like what kind of device is it?
Exactly. It looks at various characteristics, the operating system, maybe the hardware vendor, the software it's running, its security posture even. Is it patched? Does it have antivirus?
So it builds a profile.
Right. To understand, is this a company-issued laptop? Is it someone's personal smartphone? Or maybe an IoT sensor, a printer?
And why do you need to know that?
Because once you understand the type of device, you can apply the right security policies to it. For example, you might grant a known, compliant corporate laptop full access to sensitive network resources, but maybe restrict a personal smartphone that hasn't been vetted to just basic internet access, keeping it away from critical systems.
I see. And that ties into authentication.
Directly. Authentication verifies the identity not just of the user, but often of the device itself as well. Is it really the device it claims to be? Does it meet our minimum security standards?
So it's not just who is trying to connect, but also what they're trying to connect with.
Yeah.
That feels much more thorough.
It is. It's a much more comprehensive approach.
Right.
And when you combine that device profiling and authentication with role-based policy enforcement...
Where access depends on your job function, right?
Exactly.
Yeah.
What resources does this specific user in their specific role actually need access to? So together, these elements create a really robust network access control, or NAC, strategy.
Yeah.
It's all about ensuring only authorized users on known compliant devices can access only the specific network resources they're supposed to. Think of it like, I don't know, a really strict bouncer at a club. They check your ID, that's the user authentication, but they also check if you meet the dress code. That's kind of like the device profiling and compliance check.
Got it. Okay, question 4 moved us to automation in hybrid IT.
Right, automation, always a hot topic.
And the big benefit highlighted was consistent policy enforcement and reducing errors. We get that automation saves time, but why is that consistency so critical, especially in a hybrid setup? With stuff both on-prem and in the cloud.
Yeah, the real challenge with hybrid IT fundamentally is managing the complexity. You've got different infrastructure environments, your own data center, maybe one public cloud, maybe multiple public clouds.
Right, different platforms, different tools.
Exactly, often with their own management interfaces, their own ways of doing things. Now, manually trying to apply the same security configurations, the same compliance rules, the same operational procedures across all these, well, disparate systems.
It's like a nightmare.
It's not only incredibly time-consuming, but it's also really, really prone to human error. Someone clicks the wrong box, forgets a step, misinterprets a setting.
And suddenly you have a security hole or a compliance gap.
Precisely. Automation offers a way to define those policies and configurations once maybe in code or using an automation platform.
Okay.
And then apply them programmatically, consistently across all your environments, whether it's an application running on your own servers or a service spun up in AWS or Azure.
So you're not relying on someone manually configuring the same firewall rule in 3 different cloud portals, plus your on-premise firewall, and just hoping to get it right every time.
Exactly that. Automation removes that manual, repetitive, error-prone work.
Okay.
It drastically reduces the chance of misconfigurations or oversights that could lead to vulnerabilities or compliance failures. This consistent policy enforcement, driven by IT automation tools, is really essential for maintaining control and security as IT landscapes get more distributed and complex.
Makes sense.
Yeah.
Okay, question 5 tackled zero trust security.
Zero trust. The big buzzword.
It is. And the core idea mentioned was never trust, always verify for every access request, plus network segmentation. That feels like a pretty radical departure from The old castle and moat network security model.
It really is a fundamental shift in mindset. Traditionally, yeah, the focus was on the perimeter, build strong walls. Once you were inside the network, there was often a certain level of, well, implicit trust granted.
Right, you're inside, so you must be okay.
Zero trust completely flips that. It operates on the assumption that threats can, and probably do, exist anywhere both outside and inside the network perimeter. Maybe an attacker got in, maybe there's a malicious insider.
So you can't assume anything is safe.
Correct. So you validate every single access request, regardless of where the user or device is located, inside or outside. Every time someone or something tries to access a resource, its identity and authorization are strictly verified.
Okay, always verify. What about the segmentation part?
That's crucial too. It's often called microsegmentation. Instead of having one big, flat, internal network where everything can talk to everything else.
Which is bad if someone gets in.
Very bad.
Yeah.
Because they can move laterally, easily, hop from system to system. Microsegmentation divides the network into much smaller, isolated segments or zones.
Okay.
So, if an attacker does manage to compromise one small segment, say one application server, they can't easily move from there to compromise the entire network. Their blast radius is significantly limited.
Concatenating the damage.
Exactly. So zero trust networking combined with microsegmentation, it's a powerful response to modern cyber threats where attackers often get inside and then move around undetected.
It sounds effective, but maybe complex to set up.
It definitely can be. Implementing it properly requires really granular control over access, continuous monitoring, and often significant changes to network architecture and security tooling. It's not a quick fix, it's more of a journey.
Understood. Okay, question 6 brought us back to AI again, this time for cloud resource optimization. And it emphasized AI's ability to predict and dynamically adjust usage patterns. How does that actually save money or improve performance in the cloud?
Right. So think about how resource needs for applications fluctuate, right? An e-commerce website, for example. Huge spike in traffic during a big sale. Then maybe it's pretty quiet overnight.
Yeah, peaks and valleys.
Traditionally, organizations using the cloud might just provision enough resources, servers, databases, whatever, to handle the absolute peak demand they anticipate.
Just to be safe.
To be safe, exactly. But that means during the quieter periods, a lot of that provisioned capacity sits idle, but you're still paying for it. It's wasted money, wasted resources.
No.
AI and machine learning algorithms can help here by analyzing historical usage data. They look for patterns, trends, seasonality.
Learning when those peaks and valleys usually happen.
Precisely. Based on those insights, they can actually predict when resource demand is likely to increase or decrease in the near future.
Grenade prediction. Then what?
Then, the clever part. They can automatically scale the resources up or down in near real time based on those predictions, or even based on current load. So when the sale starts, it automatically adds more servers. When things quiet down, it scales back down.
So it's like having your cloud infrastructure automatically resize itself based on actual demand. You're only paying for what you genuinely need at any given moment.
That's the goal. This dynamic scaling, often driven by AI and machine learning capabilities within cloud management platforms, aims to ensure applications always have the resources they need to perform well.
Good performance.
But without the cost inefficiencies you get from just sedatically over-provisioning everything, it's about getting the right amount of resources at the right time, more efficient both technically and financially.
Very clever. Okay, question 7 then. It highlighted a big challenge: ensuring consistent data governance policies across different platforms in multi-cloud environments.
Ah, yes, the multi-cloud data governance headache.
Why is that such a pain point for organizations? It sounds simple, just apply the same rules everywhere, right?
If only it were that simple. The complexity really stems from the fact that each major cloud provider, AWS, Azure, Google Cloud, others, they all have their own unique set of services, their own policy engines, their own compliance frameworks, their own tools.
They don't all work the same way?
Not at all. There isn't really a standardized one-size-fits-all approach to data governance that works seamlessly across all of them out of the box.
Okay.
You have different tools for classifying sensitive data, different mechanisms for setting up access controls, different ways of auditing and proving compliance with regulations like GDPR or HPE.
Right, so the same rule might need to be implemented differently on each platform.
Exactly. Trying to maintain a consistent data governance posture, ensuring the right data is protected in the right way, no matter which cloud it sits in across all these diverse platforms. It requires really careful planning, orchestration, and often specialized third-party tools that can kind of bridge those gaps and provide a unified view and control plane.
It sounds like you almost need a translator and a master rule
Yeah.
book to keep everything aligned.
That's actually a pretty good analogy. Managing policy and data governance across multiple clouds is definitely a significant challenge as organizations increasingly adopt multi-cloud strategies.
Okay. Question 8 shifted gears a bit towards IT sustainability,
Green IT, yes, increasingly important.
and it pointed to two key strategies: consolidating data centers and using energy-efficient hardware. Beyond just, being better for the environment, do these strategies offer other tangible benefits to a business?
Oh, absolutely. While reducing the environmental footprint is definitely a primary driver for many.
And becoming more important for investors and customers, too.
True. But both data center consolidation and using energy-efficient hardware can also lead to pretty significant cost savings.
How so?
Well, consolidating data centers, reducing the number of physical facilities you operate directly translates to lower energy consumption. Less power needed for servers, storage, networking, and crucially for cooling, which is a huge energy hog in data centers.
Right, lower electricity bills.
Lower electricity bills, possibly reduce real estate costs if you close facilities, maybe lower maintenance overhead. And with energy-efficient hardware servers, storage arrays designed to consume less power for the same performance while they might have a slightly higher purchase price upfront.
Okay.
They consume less electricity over their entire lifespan, so your operating expenses go down. These green IT practices and focusing on sustainable infrastructure, they're increasingly seen not just as corporate social responsibility, but as genuinely smart business decisions that impact the bottom line.
So going green can literally save you green.
Precisely. It's a win-win in many cases.
That's a compelling point. Okay, question 9 brought machine learning back into the picture.
Seems to be a recurring theme.
It does. This time, specifically for anomaly detection in networks, emphasizing its ability to spot unusual patterns that might signal a threat. Can you give an example of an unusual pattern that ML might catch, but maybe traditional security tools would miss?
Sure. Traditional security rules are often based on known bad things, specific malware signatures, IP addresses associated with attackers, attempts to exploit known vulnerabilities. They're good at catching what they're programmed to look for.
Okay. The known unknowns, so to speak.
Kind of, yeah. Machine learning, on the other hand, excels at establishing a baseline of what's normal behavior for your specific environment, for users, for devices, for network traffic flows.
Learning what good looks like.
Exactly. And then it looks for subtle deviations from that established norm, things that might not trigger a specific predefined rule, but just look odd.
Like what, for instance?
Well, maybe ML notices a user account that normally only logs in from London during UK business hours, suddenly authenticating from, say, Eastern Europe at 3 a.m.
Okay, that's suspicious.
Or perhaps a server that usually only sends small amounts of data suddenly starts uploading gigabytes of information to an unknown external address. Or maybe a user's machine starts communicating with internal systems it has never interacted with before, in a pattern that looks like reconnaissance. These seemingly small deviations may be individually not enough to trigger a classic alert, but when analyzed together by an ML system...
They paint a picture of something potentially malicious.
Exactly. They could be early indicators of a compromised account, data exfiltration, or a sophisticated, slow-moving attack. This kind of behavioral analytics, using ML for threat detection, adds a really crucial layer of intelligence beyond just signature matching. It helps find the unknown unknowns, potentially.
Got it. Looking for those subtle shifts in behavior that just don't feel right. Okay, fascinating. Finally, question 10. This one highlighted the importance of visibility in managing hybrid cloud environments.
Visibility, yeah. Can't manage what you can't see.
Exactly. And it specifically mentioned tracking data movement and ensuring compliance. Why is knowing where your data is and where it's going so critical in a hybrid setup?
Well, think about it. In a hybrid cloud world, your data isn't just sitting nicely in one place anymore. It can be spread across your own on-premise servers, maybe in one public cloud, maybe multiple public clouds, potentially even out at the edge on IoT devices.
Data is everywhere.
Data is everywhere. And without comprehensive visibility, without tools and processes to actually see where sensitive data resides, who's accessing it, and how it's flowing between these different environments, it becomes incredibly difficult, maybe impossible, to manage effectively.
What are the risks of that lack of visibility?
Several big ones. Security vulnerabilities, for one. If you don't know where your sensitive data is, how can you be sure it's properly secured everywhere?
Good point.
Compliance violations are another huge risk. Regulations like GDPR, HPE, PCI DSS, they have strict rules about how personal or sensitive data is handled, stored, and transferred. If you can't track your data's location and movement across your hybrid environment, proving compliance becomes a nightmare.
Right, auditors aren't going to be happy.
Definitely not. And then there are operational issues, too. Difficulty troubleshooting performance problems if you can't see the entire data path. So, having robust monitoring and observability capabilities specifically designed for hybrid cloud is absolutely essential. It provides the insights you need to manage risk, ensure data security, meet those regulatory requirements, and just generally keep the whole complex ecosystem running smoothly.
Absolutely. You really do need that clear line of sight, that map of your data's journey to protect it properly every step of the way.
Couldn't agree more.
We've just discussed, from AI-driven security and optimization to sustainable practices to managing data across hybrid and multi-cloud, all underpinned by zero trust and automation. What do you see as maybe the single biggest shift or the biggest challenge perhaps for organizations trying to really thrive in this landscape going forward?
It really makes you think about how all these individual threads weave together, doesn't it?